Two lines capital AB and AC makes an angle of 120 degree between them in their front view and top view. Capital AB is parallel to both HP and VP. Determine the real angle between capital AB and AC. So this is the problem. So here, two lines capital AB and AC. So that means he has given the true length. Makes an angle of 120 degree between them in their front views and top views. Capital AB is parallel to both HP and VP. Determine the real angle between them. Real angle means the true angle between AB and AC. So first is, he says capital AB is parallel to both HP and VP. So and he has not given any distances, so we can take whatever the distances we want. So from XY line you take any convenient distance and draw a horizontal line. And similarly from the XY line below XY line you draw any one horizontal line. Consider any point from here, draw a vertical projector so that it will go to cuts B dash in the front view and B in the top view. Then you assume any distance. Say for example we are going to take around 60 mm length. You are going to take around 60 mm length and draw one more vertical projector so that mark this point as A dash and A. So this is a line K is parallel to both HP and VP. So you can see capital AB is parallel to both HP and VP. So we're going to consider this as capital A and this as capital B and this as capital A and this as capital B. So this will be top view and this is the front view which is parallel to both HP and VP. The two lines capital AB and AC make an angle of 120 degree between them in their front views and top views. So from here you measure by using the protractor, you measure an angle of 120 degree with respect to the horizontal and then mark that point and then draw a line which is at 120 degrees. And similarly with this as center, since this is 120, so obviously this should be 30 and this should be 30, so that it is going to become 180. So with B dash as center, by using the protractor you measure an angle of 30 degree and then draw an inclined line so that it will go into cut this inclined line at this point which is going to become C dash. And you dark all the three lines which is A dash, B dash and C dash. So this is going to make an angle of 120 degree in their front views and top views. So this is the true length, but this line will going to be inclined and this also be inclined in their front views and top views. So this is actually the front view what he has given. This is also the front view what he has given. So you are going to get this point as C dash. Then again with A as center, by using the protractor we measure an angle of 120 degree with respect to the horizontal and then draw an inclined line here. Similarly with B as center, measure an angle of 30 degree with respect to the horizontal and then draw an inclined line so that it will go into cut this point here. So since it is the top view, you make this capital A, you draw A to B, B to C and C to A with a dark line and then you project this. So this will going to be the one, it will be in line with the C, both C and C dash will be in line with each other. So this will going to become the front view and this will going to become the top view. So we need to find out the real angle, means it is the true angle, that is the true inclination has to be found out between AB and AC. But now we know that this is already in true length, that is A dash, B dash and AB is already in true length because it's parallel. Now when you are considering A dash, C dash, so this is the front view because the top view line is inclined. So this is the top view because it is the front view is inclined. So now what we need to find out? We need to find out the true length. So which is the true length? First we need to find out the true length of AC, and also we have the true length is AB and A dash, B dash is in true length, and since B dash, C dash is the line which is inclined to HP and BC is the line which is inclined to VP. So this is the top view and this is the front view. Now we need to find out the true length of A dash, C dash and we need to find out the true length of B dash, C dash. With A as center, take the radius of AC by using the compass. You draw an arc such that you make that line AC1 which is parallel to VP. Once you make the parallel to VP, so you will going to get the true length in the vertical plane. So how to get this point? So once with A as center, when you rotate C with respect to A, so AC1 will be the line which will going to be parallel to VP. So with A is here, C is moves in a straight line here, then you project this point from C1 directly onto the locus of C in the front view. So once you will do that, so you will going to get this point C1 dash, mark this point as C1 dash, then join A dash C1 dash with little bit thicker than the projector line. So this will going to be the true length for AC. So now we found out the true length of AB and true length of AC, which is already found out. Now true length of AB is already there because it is parallel to both HP and VP, which is given in the problem. Now we need to consider BC now. So BC is inclined to VP and B dash C dash is inclined to HP. So now we need to find out the true length of BC. So with B as center, take the radius of BC, then draw an arc such that it will going to become parallel to VP. So this point will going to become C2. Then you project this point C2 onto the locus of C in the front view. So you are going to get this point. So this will going to be the C2 dash. So this join B dash C2 dash with little bit thicker than the projector line. So this will going to be the true length of BC. So since we found out all the true lengths of the three lines, now we want to find out the real angle between them. So with B dash as center, take the radius of B dash C2 dash and draw an arc by using the compass. Again with A dash as center, take the radius of A dash C1 dash, again draw an arc such that it will going to cut the previous arc at C3 dash. So this will going to be the actual true length which will be there here. So when it is joined, it will going to become the triangle. So this will going to be C3 dash, which will be capital C. So join A dash to C3 dash and B dash to C3 dash. So this will going to be the real angle theta, which will going to be the true inclination with respect to HP. So this will going to be theta. Then by using the protractor, you measure an angle of theta with respect to the horizontal, which will be 112 degrees when you are doing it in manual. When you are doing it in computer, it will be 112.21 degrees. So this is how we will be able to solve this particular problem.